Alright, so in this video I want to go over this example 8 from section 1.1 in the book. So the reason I want to do this is that I want to get us closer to thinking about matrices and illustrate that through the example that they did. So here we have three equations relating x1, x2, x3, and we notice that because the second equation has a 2 out front, we can subtract 2 times the first one from the second to eliminate that 2. And rewriting all the variables sounds like a whole lot of work. So what I'm going to do is I'm going to turn this into a matrix where the first column is the x1 coefficients, the second is the x2, third is the x3, and then the fourth we'll call the b, the constants. So in this first column, we'll have the coefficients of x1 in each equation. 1, 2, 1. The second column will have minus 3, minus 1, 2. And then the third column, 1, minus 2, minus 3. I like to put a dashed line right here to represent where the equal signs are. And then a 1, a 2, and a minus 1 for the b's. Alright, so then this act of doing minus 2 times the first row, first equation, plus the second equation, replacing the second equation, is going to look like we're going to take the second row and we're going to subtract 2 times the first row. Alright, and we will denote it in this way. So we get 1, minus 3, 1, 1 is still our first row because we haven't changed the first equation. The second equation then becomes a 0 in the first spot because we do 2 minus 2 times 1. Alright, and really that's what we wanted there anyway. We wanted a 0. Alright, then we get a minus 1 minus 6, so we actually get a 5 there. Minus 2 minus 2 is negative 4. And then 2 minus 2 is 0. Right? And then, again, we also didn't change the third equation, so that'll stay the same. Alright, so notice we've essentially done exactly what the book's done. We've just simplified our writing. We don't have to write all those x's. Alright, so then the next task was to do minus 1 times the first equation plus the second equation. The third equation. Let's fix that. Alright, let's spell second right. Alright, and so again we do R3 minus R1. Row 3 minus row 1. Alright, 0, 5 minus 4, 0, 0. 2 minus negative 3 is going to give us a 5. Minus 3 minus 1 will give us a negative 4. And a minus 1 will give us a negative 2. Alright, and at this point, we notice there's a lot of similarity between these second and third line here. And if we think about that in equation form, what it's saying is that 5x2 minus 4x3 equals 0. And 5x2 minus 4x3 equals negative 2. And well, that just doesn't make any sense, that we have 5 times one thing minus 4 times another thing equals 2 different numbers. Okay, so this is not possible. So our system is definitely inconsistent. There is one thing we could do. We could go a step further with our rows and equations. We could take the third row minus the second row, replacing the third row. 0, 5 minus 4, 0. So this first and second row stay the same. The third row then has zeros in all of the coefficient spots, but here at the end we have a minus 2 still. So if we now turn that back into equations and think about what that means, let me grab a different color. Alright, this says that 0 equals, this is really thick. Alright, let's make this a little thinner. 0 equals -2. Okay, which this is definitely not possible. Definitely wrong. Right, everything we know about numbers, and so I'll put a lightning bolt to say there's a contradiction. We'll say this is inconsistent. Right, so you can stop whenever you sort of know for certain that it's inconsistent. If at this point we got some number here instead, let's say if like this was a 1 here, then our system would be consistent. We'd have an x3 equals -2. We'd have a 5x2 minus 4x3 equals 0. Alright, so we can already back substitute our x3 value in to find out what x2 is. Alright, and then lastly we can do the same thing with x1. So it's really these zeros being all the way through here that is really messing everything up. Alright.